So besides quadratic equations, there's a couple other types of equations that you should be familiar with for the final exam. The first of which is radical equations. And we have two examples here of the varying difficulty of radical equations that you would see on the final exam. So let's see how to do a couple of these. First off, if we look at the first one, if I want to solve this radical equation, I'm going to need to get rid of this square root. That's kind of my problem. So if I add x to both sides of this equation, I'm able to isolate this square root. 2x plus 7 equals x plus 2. And then if I want to get rid of it, what I can actually do is square both sides to get this radical to go away, since squaring is the inverse operation of square root. And whatever I do to one side, I do to the other to keep my equations equal. And I end up with 2x plus 7, because the square and the square root will cancel out, equals this squared, which when I FOIL will be 2x squared plus 4x plus 4. So that's using the perfect square property. You could also write this as x plus 2 times x plus 2 and FOIL it out. Whichever way you choose, you'll get this. Then I bring everything to one side, end up with 0 equals x squared plus 2x minus 3, which factors to x plus 3 times x minus 1, which tells me that either x is 3 or x is 1. Sorry, that's a negative 3 or x is positive 1. Now the last step that you need to do when you're dealing with radical equations is that sometimes one of these two solutions might not actually work. So we do need to plug them back in for x and check. So if I plug in negative 3 here, I end up with 2 times negative 3, which is negative 6 plus 7, would equal square root of 1, which is just 1, minus negative 3 again. Minus negative 3 would be plus 3, so 1 plus 3. And does that equal 2? Well, 1 plus 3 is 4, so that does not equal 2. So what we're going to do is reject this solution because it did not check. Now the last one to check is the 1, so I'm going to go up here and plug in 1 instead. When I plug in 1, it'll be 2 times 1, which is 2, plus 7 would be 9. The square root of 9 is 3, minus 1 equals 2. And that one does check, so it looks like my only solution is actually x equals 1. Now the reason we get some solutions that don't work is that by squaring the square root, we're getting rid of the sign value. So this actually negative signs over here turned out not to work when we plugged it back in. So remember that you always must check your solutions when dealing with radicals. It's when you must check, because sometimes you get answers that you would reject when otherwise you would keep them. One slightly more complicated version of this is when you have two radicals, but the process is the same. I'm going to isolate one of the two. It doesn't matter which one you isolate. For me, I'm going to isolate this first one to get rid of one radical, and then you'll have to repeat the process for the second. Sorry, that's a minus. Where's the undo button? There we go. So this is the square root of 2x minus 5 equal to, and if I add this radical to both sides, it'll be the square root of x minus 3 plus 1. Now, what happens when I square it this time is, again, I'll have to FOIL the right-hand side, but what ends up happening is that I'll end up with an extra radical in the middle. So when I expand these values, I end up with the square root, the square cancel out. I have 2x minus 5. And over here I have to FOIL, and when I use you can either write it as two factors in FOIL, or you can use the perfect square pattern, which is what I'm going to do. I'll have my first term squared, the square root squared cancel out, so it'll be x minus 3 plus 2 times the product of the two terms, which is square root of x minus 3, and then plus last term squared is 1. So I'm going to combine all my like terms. I'm also going to isolate this square root. So to do that, I'll subtract x, add 3, and subtract 1 from this side. And whatever I do to one side, I also need to do to the other. So I will subtract x, add 3, and subtract 1 from this side as well. Well, 2x minus x will leave me with x. Negative 5 minus 1 is negative 6, plus 3 is negative 3, equals x minus x cancel out. Negative 3 plus 3 cancel out. 1 minus 1 cancel out, and I'm left with just this radical. Now, the reason I isolated that radical again is because I again need to get rid of this radical, so I'm going to repeat that same process as the beginning and square both sides. I end up with x squared minus 6x plus 9 is equal to, I have to distribute this exponent, so 2 squared is 4, and the square root of x minus 3 squared is just x minus 3. So what I end up with here is x squared minus 6x plus 9 is equal to, distribute my 4x minus 12. Get everything to one side, x squared, subtract 4x from both sides will be minus 10x, and add 12 to both sides. 12 plus 9 is 21 equals 0. I need some more space, so I'm going to scroll down. I then need to try to factor this. Well, what multiplies to 21 and adds to negative 10 would be negative 7 and negative 3. So I end up with either x equals 7 or x equals 3. So my last step is to check these in my original equation. So I'm going to plug in 7 first. Bring it back up here. 2 times 7 is 14. 14 minus 5 is 9. Square root of 9 is 3. Minus 7 minus 3 is 4. Square root of 4 is 2. 3 minus 2 equals 1. So 7 works. 7 will be one of my solutions. The other one I need to check is 3. So I'm going to plug in 3 now. Taking my pen. Here we go. So I'm going to go over here, plug in 3. 2 times 3 is 6. Minus 5 is 1. Square root of 1 is 1. Minus 3 minus 3 is 0. Square root of 0 is 0. And 1 minus 0 equals 1. So it looks like both of my answers checked. So those will both be solutions. So my final solution set is x equals 7, x equals 3. Final answers. Both checked, both are solutions. Now, the last type of radical expression you could see is when involving rational exponents. So these were both using square roots, but remember that radicals can also be expressed as rational exponents as they are here. So if I want to get rid of that rational exponent, I kind of need to multiply that rational exponent by 2/3 to get these two fractions to cancel out. Well, recall that multiplying exponents would be exponents raised to exponents, so I'm going to take both sides of this expression and raise it to the 2/3 power. And whatever I do to one side, I also need to do to the other. Well, x minus 5 to the 3/2, to the 2/3, I would multiply these two exponents, because exponents raised to exponents you multiply. 3 divided by 3 is 1, 2 divided by 2 is 1, so this whole left-hand side just becomes x minus 5 equals 8 to the 2/3. Well, recall that fractional exponents are roots, so 8 to the 1/3 power is the cube root of 8, which is 2. So I'll actually write it out. This is the square root, that is the cube root of 8 raised to the 2nd power using that rational exponent property. Well, the cube root of 8 is just 2, so this is equal to 2 squared, and 2 squared is just 4. So x minus 5 equals 4. Add 5 to both sides, and it turns out x equals 9. If you plug this in again, 9 minus 5 is 4. Square root of 4 is 2. 2 cubed is 8. So 8 equals 8. Checks. So that works. So that's all different types of radical expressions, radical equations. Absolute value equations. Now remember that an absolute value can be either positive or negative. So the two situations where these two things will be equal is when either 2x minus 1 is equal to positive 5, because the absolute, when this 2x minus 1 is equal to 5, the absolute value 5 is equal to 5, or when 2x minus 1 equals negative 5. So there's two possible outcomes, because when this inside stuff is negative 5, the absolute value of negative 5 is 5, and the absolute value of positive 5 is 5. When I solve this, I get 2x equals 6, which means that x is 3, or 2x equals negative 4, which would mean that x is negative 2. So I get two possible solutions. The last thing I need to do is check both of these, just like with the radical equations. When I plug in 3, 2 times 3 is 6, minus 1 is 5. So I get this. And negative 2, 2 times negative 2 is negative 4, minus 1 is negative 5, and the absolute value of negative 5 is 5. So both of these solutions work, and I get a solution set of 3 and negative 2 for x. For the other one, similar situation. Doing it in a different color. The only thing is that my absolute value is not yet isolated, so in order to solve it, I need to isolate it just like we did over here. So I'm going to bring the 6 over. Get 3 times the absolute value of x plus 4 is equal to 6, which tells me that the absolute value of x plus 4, when I divide both sides by 3, must be 2. And again, I get two solutions. Either that stuff inside of the absolute value is positive 2, or that stuff inside of the absolute value is negative 2. Because when I plug this x plus 4, replace it with negative 2, the absolute value would be positive, and the same for the positive value. So that my two solutions are either negative 2 or negative 6. Again, if you check negative 6 plugged in here, I get negative 6 plus 4 is negative 2. Absolute value negative 2 is positive 2. 2 times 3 is 6. 6 minus 6 is 0. Same thing if I check for negative 2. Negative 2 plus 4 is 2. Absolute value of 2 is 2. 2 times 3 is 6. 6 minus 6 is 0. So both those answers check, and those are my solutions.